All right, welcome. Now what I'm going to do is we're going to talk about the derivation of the standard equation for an ellipse, and we're going to make it simple by dealing with it centered at the origin first. Once we derive that, then the rest of it will make sense going forward. That what if it's not centered at the origin? Okay. So again, what we're going to do is we're going to use the fact that the definition of the ellipse is that the distances of the foci to a specified point on the graph of an ellipse must be constant. The sum of those two distances must be constant. So we're going to simplify it by saying, okay, let's just pick one point that we could easily calculate, and then go from there and see if we could derive the general formula, the equation for any point on the line. Okay, so first of all, we're going to use the fact that we want to basically describe what this constant looks like. So we're going to use this example here where we have an ellipse with the major axis. So again, the major axis is the longer axis, right, where the vertices are. So that is the major axis. The other axis is the minor axis. So we're starting with the major axis on the x-axis. Okay, we'll do it for this one, but then it becomes obvious how it would be for what if it was elongated on the y-axis, for example. So in this case here, we've got the two vertices. Remember, the vertices are always located on the major axis, and also the foci are also located on the major axis. Okay, so we've got arbitrary points made. So focus 1 is at negative c comma 0. Focus 2 is at positive c comma 0. So they're equidistant from the center as they should be. And then the vertices are also equidistant from the center. And so vertex 1 is at negative a comma 0, and we've denoted vertex 2 as at a comma 0. Then we have an arbitrary point. We'll talk about that in a moment. So we have an arbitrary point picked on the graph of the ellipse at x comma y. And we've also notated the distance d1 and d2 from this given point to both of the foci. Okay, so now let's start with a real simple example to get an idea again what the constant looks like, right? That constant number that the sums of the distance should always add up to. So if it works for all of the points, by definition, then it should also work for the point of the vertex v2, which is right on the x-axis, which will make the calculations very simple for us. Okay, so if we take the distance from f1, right? So if we take the distance from f1 to v2, right? The distance from here to here, from f1 to the origin, is c, right? And then the distance from the origin to the vertex is a. So the distance from f1 to v2 is c plus a, right? Now, let's take the distance from f2 to v2. So that distance would be what? Well, in this case here, we would subtract because we need to find this distance. So we're going to take the larger distance from the origin to the vertex, which is a, and we're going to subtract off the smaller distance from the origin to the second focus. Okay, so, or focus 2. So that's going to be what? A minus c. Okay, now, if we take those two distances, right? If we take those two distances and add them up, what do we get? Well, here the c's cancel and we get 2a. So that means that's what our constant will be. In fact, by the way, this is the length of the major axis, incidentally. So 2a, so that is our constant. So now let's go with any point on here. So we know that d1 plus d2 for any point on the ellipse, the graph of the ellipse, is going to be equal to 2a. So d1 plus d2 must equal 2a. Now what we're going to do is let's take any point xy. Okay, we're going to use the distance formula to represent D1 and D2. So the first thing we're going to do is the first distance is going to be what? From this point to this point. So negative c comma 0 to x comma y. And again, using the distance formula, that's going to be what? It's going to be y minus 0 squared plus x minus a negative c, which would be plus c, quantity squared. Okay, that's D1. Now let's do D2. That's going to be the square root of what? It's going to be y minus 0 again, squared, plus x minus c, quantity squared. Okay, and of course all of this has to equal 2a. So now what we're going to do is I'm going to go through as quickly as I can to solve this as easily as I can because what we want to do is we want to get rid of the radicals. Okay, so let's do that. So the first thing we're going to do, if you remember, we have to isolate one of the radicals because we've got two of them. So we'll just isolate one of them. It doesn't matter which one. So we'll just isolate this one. So this will become this. Okay, so this is going to equal 2a minus y minus 0 squared plus x minus c, quantity squared. Okay, so now what I'm going to do is simplify things. This is just y squared. So this is going to be the square root of y squared plus x plus c, quantity squared, is going to equal 2a minus the square root of y squared plus the quantity x minus c, quantity squared. All right, so now what I'm going to do is I'm going to square both sides. So I'm going to square this side, and I'm going to square this side. And so now this is going to get rid of the radical over here, so I'm just going to end up with y squared plus the quantity x squared plus c, oops, not x squared, sorry, x plus c, quantity squared. And then over here, I'm going to use the distributive property because I've got a binomial here. So this is going to be 4a squared minus 4a times the square root of y squared plus the quantity x minus c, quantity squared, and then plus, hold on a second here, yeah, plus and then this is going to be squared, right? So this is going to be plus y squared plus the quantity x minus c, quantity squared. All right. Okay, so now let's move everything over and isolate this, see what happens here. Well, right away we could see that the y's are going to cancel out. Is that right? Hold on a second here. So this is going to be 4a squared, and then we got minus 4a times this, and then plus yeah, that's right. Okay, so now let me simplify this a little bit. So the y's are going to cancel. And let's move everything over except for the radical. So let's do so that we'll have x plus c quantity squared minus x minus c quantity squared minus 4a squared equals negative 4a times the square root of y squared plus the quantity x minus c quantity squared. All right, so that's where we're at. So let's go back up to the top here. And I'm going to erase this here. Give myself some room here. And I'm going to, okay, leave there. Okay, so now, here, let's expand, let me see here. Yeah, let's expand these out and see what we get. So this is going to be x squared plus 2cx plus c squared minus the quantity x squared minus 2cx plus c squared minus 4a squared equals negative 4a times the square root of y squared plus the quantity x minus c quantity squared. All right, so now here we go. I'm going to start writing smaller. So now this is, let me just distribute the negatives here. So this is going to be negative, this is going to be positive, this is going to be negative. All right, so that's what we have here. So we've got a plus c squared here and a minus c squared here. So those are going to cancel, right? We got a cx here, and we got an x here, so these are going to cancel. So what do we end up with? We end up with 4cx minus 4a squared, which equals negative 4a times the square root of y squared plus x minus c squared. All right, so now we're going to divide both sides by negative 4a. And this will become so this will become cx, so negative cx over a minus, or no, plus a equal to the square root of y squared plus the quantity x minus c quantity squared. All right. Now we square both sides, right? And so when we do that, what do we get? We get, this is going, okay, so this will give us what? This is going to give us c squared x squared over a squared minus this times this, which is just going to give us what? Negative 2 cx plus a squared, which is then equal to y squared plus x minus c quantity squared. Okay. Okay, so now let's continue going on. So we've got c squared x squared over a squared minus 2cx plus a squared equals y squared, and then this is going to expand out to plus x squared minus 2cx, which then gives us plus c squared. Okay, so now the 2cx, the minus 2cx is going to cancel out. Okay, so now let's go back to the top and see where we're at here. Let's multiply everything by a squared, see what we get. We get c squared x squared my plus a to the fourth equals a squared y squared plus a squared x squared plus a squared c squared. Okay. Now we've got an x squared here and x squared here, so let's bring those over. So let's subtract off a squared x squared. And then we've got an a squared here. Ooh, hold on. Oh, but that's got a y. Okay, we've got an a squared here and an a squared here. So let's see. Actually, let's do it the other way here. I want a squared minus c squared. So let's do this. Minus c squared x squared minus c squared x squared. And then we're going to do minus a squared c squared minus a squared c squared. All right, so now what we got is this will go away, this goes away, and we end up with a to the fourth minus a squared c equals a squared y squared plus a squared x squared minus c squared x squared. All right, cool. So now, if I factor out an a squared here, I got a squared times a squared minus c squared equals a squared y squared. And I can also factor out an x squared here, so this would be plus x squared times a squared minus c squared. All right. Now that's where we want to be. Now, we know the distance between the two foci from our diagram. Remember the two foci, F1 and F2. Remember this is a negative C0 and this one's at positive C0. So the distance between the two is equal to 2 times C. Okay, so we know the distance between the two foci is 2c, and we know that the distance between the point on the graph, right? We know that these distances have to be equal to 2a. Okay, now we know again from the diagram that this distance, right, has to be less than the distance between the points, right? The sum of the two distances, 2a. So we know that 2c has to be, right? I mean, it's obvious from the diagram we've talked about before, 2c has to be less than 2a, right? So we know that 2a has to be less than, 2c. 2c is less than 2a, which implies that c is less than a, right? Which then also implies what? Well, if I squared both sides, well, let's just keep going. So this means that c squared has to be less than a squared, which means that c squared minus a, do I want to do it that way? C squared minus, I want to do a squared. A squared, so that means that a squared minus c squared has to be greater than 0. That's where we want to go, okay? So a squared minus c squared has to be greater than 0. Okay, now, so we know it has to be positive, right? So we know that these values have to be positive, whatever they are. So let b equal this difference, a squared minus b squared equals a squared minus c squared. Okay, so now what does it give us? How does that help us? Well, let's do it. Okay, so let's substitute in there. So now this becomes a squared times b squared is equal to a squared times y squared plus x squared times b squared. All right, so now we're almost there. We're almost there, okay? So now it just basically falls apart and simplifies real nicely, because now all we're going to do is divide everything by this constant, a squared, or whatever, this number, right? This real number. So a squared, b squared, a squared, b squared. So now what happens? This becomes 1. These cancel, so this becomes y squared over b squared. And this becomes what? X squared over a squared. Okay? And voila, that is the standard formula. So again, we usually write it this way, so it'll be x squared over a squared plus y squared over b squared is equal to 1. Okay? So now notice a is the length of half of the major axis. We call that the length of the semi-major axis. B is the length of the semi-minor axis. Notice how A is always below the major axis, where the major axis is. So in this case here, the major axis was along the x-axis. A is always over that. Now if it was the other way, then it would switch. A would be over here under the y, so the B and the A would switch if it was if the major axis was going along the y-axis. Okay, but that's it. That's the derivation. I hope you enjoyed it.